Hello, this is Junichiro Horikawa, and today I would like to show you how to create this animated snake-like scale geometry using geometry nodes in Blender 3.0. First, going to explain the algorithm used in this tutorial, and then I'm gonna show you step by step how to implement that algorithm in order to create this kind of shape together with some simple loop animations. I'm also going to implement some parameters in order to control the overall shapes. Like shown in here, you can control the size, like the height, also a size, how much turns you want to have, the resolutions, how many scales you want to have on top of this shell, and the size of the radius, and also a scale of scales, the angle of the scales, and so on. So these are the parameters that I'm going to implement during the creation of this patch on geometry nodes. The algorithm used in this tutorial is pretty simple. It is called as logarithmic spiral, which is sometimes called as Fibonacci spiral as well in some context. And you could find an equation in order to create this spiral curve right here, and it is also represents this kind of ammonite shell, nautilus shells shape. So I'm gonna use this algorithm in order to create the outline of the overall shape. So let's start creating the geometry using geometry nodes, and the first thing I'd like to do is to create the outline curve, which is going to be the center of the shell. Then I'm going to create a pipe shape from this outline curve, outline spiral curve. Then in the last, I'm going to use the instance to plot or place those scales on top of those pipe shape. Okay, so let's check what kind of algorithm we can use in order to create this kind of curve. For this algorithm, logarithmic spiral. And there are several coordinates explaining how to create this. And I think the easiest way to create this is using this polar coordinates, using the radius and the angle. So this is the R is the radius of the points on specific points together with the angle at this specific points. So by specifying the angle, you can get this radius from this equations. So you have a parameter a and also a k on the power of exponential value, and you also have this angle value. It says phi in this case. So I'm just going to use this equations, simple as it is, and try to first of all draw a curve based on these equations. So let's do this. I'm gonna show this up somewhere on the bottom or somewhere on the top. Okay. And let's open up the geometry nodes. And I'm just going to use this cube to place the geometry nodes. I'm just going to remove the cube itself. And first of all, trying to draw a curve using this algorithm with some parameters like a, k, and phi, and exponential values. So what we need to do here is to create the radius together with the angle. So let's first set some angle values, and I think it makes sense to define like how many turns you want for the spiral shell. Like if you want 3 turns, it's gonna be like 3 multiplied by 360 degrees and so on. So let's try to have those parameters first of all. I'm gonna create a math node, multiply it with 360, which is going to be counted as degrees, and I'm also going to create your own parameter, which I'm gonna call it as turn, to define how many how many rotations you want for this shells. So if it's 1, you have 160 degrees, like single cycle turn. If it's 2, you have 2 turns, and so on. So let's say I would like to have 3 turns for now. Okay, now, since we do need to convert this into radians in geometry nodes for the angles, let's have another math node, make it as radians, convert the degrees to radians, like this. Now, in order to create a curve with specified point positions for control point positions in geometric nodes, there is no such nodes like polyline or something like that, so you do need to convert, change the point position on pre-made curve geometries. In this case, I'm going to use, first of all, I'm going to use this curve line, which initially only have 2 points, one on the start and one on the end. And what I'm going to do is to resample this curve so that I can recreate this curve, recreate this line curve line to have as many points as I want. So in order to resample a curve, you connect this curve line into resample curve with the curve input, and by changing this number you can have as much point as you want. I'm gonna try to make this parametric or procedural by relating with the number of turns with this count together with another parameter which is going to be used as a resolutions or number of scales on top of the file. So I'm gonna create another integer parameter here. I'm gonna name this section resolutions, and let's say 16 for now. And what I am going to do in order to relate these two parameters together, I'm just going to multiply this using math node, change it to multiplying section resolutions by turn. Then gonna use this for a number of points on this curve. And I'm also gonna change this curve. Let's show this up as a geometry output for now, and let's see how it looks like. Now currently the curve is facing upward, but what I would like to do is to make this facing in X direction instead of Z, and shown something like this. I don't really need to care about the size of this X coordinates. What I need is the number of points right here. Now that I have the number of points here on top of the curve, which you cannot really see on the viewport, but you do actually have a number of points here. If you look at the spreadsheet, there you go, you have a bunch of points. Right now you have like 48 points on top of a curve. Now what I'm going to do is to modify the point position of this curve using the algorithm shown here, the equations shown here, and recreate this curve into a spiral curve. That's what I would like to do here. Okay, so in order to do that, we do need some additional parameters like A and K. And we also need to create this phi at the angle value based on the index of this each point on top of the curve. So let's start by creating this index value. Okay, so in order to do that, what you could do is to first of all create an index, which is going to be the field value, indicating the point numbers on top of the curve, which is these values on the left on the spreadsheet from 0 to 47. Okay, and what I want to do here is to convert this 0 to 47 values into 0 to 1. Okay, but so to normalize it for easy usage, it's always a good idea to remap these values into 0 to 1 and we call it normalizations. So in order to do that, we do know the total number of points, which is calculated right here. In this case, we have 48 I think it's a good idea to actually indicate that this is a integer value. So let's make this floor so that we do have an exact integer value from this output, and this value should be equal to 48. Okay, and the integer value, the index value, is in between 0 to 47 in this case. So if we want to have a value between 0 to 1 by converting this one, what you need to do is to calculate the divisions between this index and this value here, the total number of points. But be careful that the last point index is 47, so it's mandatory to subtract the total number of points by 1 first, then use this to divide with the index. Then you get a value in between 0 to 1 as a normalized value. Now that I have this normalized value from 0 to 1 for the curve, I can now multiply this value together with the total angle of the spiral curve. Then you'll be able to create the step angle in order to rotate the curve. So let's do that. I'm going to multiply the total angle together with this normalized value. Then you'll be able to create a step angle value in order to rotate the points. So let's try rotating the points without thinking about the logarithmic spiral for now. Just try to create the normal spiral curve out of this value. So this is the angle, and in order to create the spiral curve, what you could do is to get the current point position of the curve and then rotate these point position as a vector using this angle value. So first of all, I'm going to get the point position of the curve, which is also a field value, and I'm going to use the vector rotate function node to rotate this position, and the center is 0, 0, 0 is fine. The axis 0, 0, 1, which is z direction, is fine, and the angle you want to use to rotate is this one. Now that I have this updated positions for each point, in order to just rotate it linearly, we could now update point position using set position node for this specific curve. And you can just replace this point positions, and there you go. You can you can create this linear spiral curve. Pretty simple. And the point positions comes from this this connection here as a field value. Also, this index is being connected to this set positions, so it's also related to this sample curve as a field value. Now that we know how to create the linear spiral curve, let's try to create the logarithmic spiral curve using these equations right here. So right here, what shown here is how you can estimate the radius of the spiral. And the angle itself doesn't really change, so we can keep this vector rotate as it is. But what we want to change is the actual radius for each point. So what we can do is to change this part right here using these equations. And currently this point position is all in x direction for our x coordinates, starting from 0 to 1. Okay, and what we want to do here is to change it to something like this. So let's try to do that. Instead of using point position derived from the original curve, I'm going to create the x coordinate positions from scratch. And right here, this is what you want to insert as a value using these equations here in order to create a spiral curve, logarithmic spiral curve. So let's see what kind of parameters we need. First of all, we have a as indicating the size, also a k indicating the exponential scaling, and also a phi, which is this angle right here. So we do need two parameters. So let's have that. I'm going to have another group input, and let's import two parameters, or let's create two parameters here. One is just gonna call this A as a float, which indicates the total size of the scale or of the spiral, and also K, which indicates the exponential scale, which shouldn't be too big because it's gonna be really big if you make it too big. So for A, I'm gonna start with value 1, and for K, I'm gonna start with the value 0.2. Okay. Now that I have A and K, I am ready to create this equations. Let's do this. First of all, I am going to create a math node multiplying A with an exponential value here. So create another math node, make this exponent. Now for the power of exponent, you have K and phi here. So you have this angle right here, and so first let's multiply this K by the angle. So let's bring this and have another math node to multiply K by the angle phi, and then bring this into the exponent value, and then have this multiplied with A. Now this whole equations is this value here, which is going to be used as the radius. So let's have this inside X. And now if we look at the output, you now already have this spiral curve, right? Easy as that. And if you change those parameters, like changing the number of turns or section resolutions, A and K. Alright, that's good. So let's change this to those values here. Now I think we are ready with the spiral center curve. It's time to create a pipe shape from this one next. So from here I'm going to reorder these, combine inside one single frame. Let's have this outside the frame. Okay. Now, in order to create a pipe shape, what I would like to do is to create a shape which covers the whole shape with some circle sections, just like you see in this Wikipedia page, something like this. Okay, I would like to create this section curve. Now, before creating the cross sections, I do want to do a little tweak to this curve. What I want to do is to move this initial point position of this curve to the center, which will make my life easier for the later process. So if we look at the radius here, the size of this offset here, it's related to this alpha value or A channel value. If I increase this value, you see that it will go far from the center using the same value. So what I just need to do is to offset this curve to the negative x direction by this value of A. So, which is pretty easy to do. You just need to multiply this A value together with -1, multiply it, and then add it together with this value, which is defining the x coordinate. So add it together with these, and then you can now offset it. offset the curve so that this initial point position comes to the center. Okay, in order to create the cross sections, what I would like to do is to create an instance on each control point on the spiral right here. In order to do that, we do need to know the radius of the cross sections curve right here, and I think we can derive that value from the point position and the x-coordinate value of this each point position, which is this value right here. Okay, or maybe this one. So let's try to use these values to create the radius of this cross sections or the diameter of this cross sections, and try to have that placed on top of this curve. Okay, so in order to do that, I am going to use the instance on points node first of all. Instance on points, and together with a circle as an instance, curved circle. And if I do this right now, it looks like this. And first of all, I think I do need to change the angle of this curve. So let's do that first. I am going to create a transform node to rotate this using x-axis by 90 degrees, and now I have a curve like this. Now, as you can see, it's still not aligned with this spiral curve right now, so let's fix that first. In order to do that, you do need to change this rotation value based on the tangent direction of this curve in order to rotate each circle along with this spiral curve. So to do that, let's use the curve tangent vector value, which is the directional value at each point which is tangent to this curve. Okay, and we do need to convert this vector value to a Euler rotation value so that I can input it in this parameter. Okay. So in order to do that, there is a node just to do that, which is called as align Euler to vector. So we're gonna use this vector for the alignments, and we're gonna figure out which part works best in order to align the curve. I think you can use y as an axis to align. And for the pivot, I'm not sure yet, so let's leave that as it is, and let's connect this to rotation. And it already seems good enough, I think. But if I use this pivot automatic, sometimes you have some glitches or errors when you change the height. So let's see which pivot works best. Now I think the Z pivot works best in this case, so I'm just gonna use this one with X instead of auto. So the combination between Y and Z works best in this case. Now we have aligned the circle. It's time to fix the size of the circle. Right now all the circle has the same size, which doesn't really fit inside the spiral. So let's try to control this scale in order to fit it. Now in order to do that, I assume that the best bet is to use the value right here, like I told you before, which is controlling the original radius coming from the equations right here. Okay, so I think my bet is that the multiplication of this value should work as a radius as well. So let's try that by calculating this value here multiplied by some additional value here, constant value here, to use it as a scale value of this instance circle. comes to this one. Okay, now it looks a bit too big, so let's make it smaller, and seems like it is working fine. Now it looks okay, so let's try to make this as another parameter. So I'm gonna create a group input again and have this created as a parameter. Let's name this cross section scale. Okay. Now what I would like to do next is to raise this overall spiral upward so that you have something more three-dimensional. It's lying on the XY plane right now, but I want to make it a bit more like a cone shape. So in order to do that, we need to go back a little bit to modify this Z value here, okay, based on a field value again. So I think it's probably a good idea to control the Z value based on this X value that I inputted right here. So just multiplying this X value with some kind of value, I think would make sense to just move in Z direction. So let's try to do that. I am going to just multiply this X value here with another constant value. Okay, multiply it like this. And if you increase it, now you can see that you are having this cone-like shape. Okay, now it's going upward, but I guess I want to make it go downward in this case, so let's make a negative value. And also, I think it's also makes sense to make this value parametric as well. So let's have another group input to create another parameter. So in this case, let's name this Z scale. Okay, now I can use this one to control the height of this cone shape. Okay, and together with this cross section scale, you can control this cross section thickness. Alright, seems to work pretty fine. Now that I have this outline, the base outline of this pipe shape, what I want to do next is to place those scales, the small scales, on top of this curve, and there is a control point on each curve. So this point position on the curve is the actual point position where we're going to place the scales. So setting up the resolution of each curve is also important here, which is defined 32 right now, but I think it also makes sense to just use this section resolutions directly for the resolutions of this curve. Okay, so let's just do that. And for the pipe part, I think this is enough. Next thing I would like to do is to place each small scale shape on top of those points. So let's do that. I'm going to create a frame, organize this a little bit, and then let's go to the next section. Okay, so let's do this by creating another instance on points. Oops. Instance on points. And what I'm gonna place now is a small circle as a scale. So in this case, I don't want to place the curve, but I want to place some face with a mesh as a mesh. So I'm gonna create a mesh circle and set the fill type to n-gon so that you don't have you just have single face for each circle, which will be useful for later uses, for later renderings. And for the vertices, You can just set any numbers for the radius. Let's set to 1m for now, and place this on instance. Now since we are using the scale, we have set the scale for each instance previously. Also, the radius of this mesh circle is also being scaled up, so seems that's not a bad idea. Yeah, so let's just keep it as it is for the scale. And what we need to fix here is the rotation, the orientation of the circle on each point. We want to make circle facing toward outside, toward the normal direction on each curve. So that's what we want to do here. Okay, and in order to do that, I think we could use another tangent value for each curve from here to create a rotational curve or rotational value. So let's try doing that. I'm going to create a tangent, curve tangent vector, and then just as I did previously, like here, I could use this align Euler to vector to create the rotation for each scales on top of the curve. Okay, so I'm gonna give this to a vector and not really show what is for the axis and what's for the pivot, so I'm just gonna leave it as it is for now, and try to connect this to rotation. And seems like it's already seems to work. It's already facing toward the normal direction, but the scale is a bit too high, so let's make the scale, the overall scale, a bit smaller by changing the scale value with the constant value. So I'm gonna try using the value, a single float value, apply for every x, y, and z. And if I make it 0.3, it already looks pretty nice here. Yeah, 0.2, 0.25. Yep. Now I do see some gaps here on the this spiral direction, so we might need to tweak a little bit on how much resolutions we have on the spiral directions where we are controlling right here. This value here, this count value indicates how many points we have on the spiral, so it seems like it's a good idea to have a double number of count on the spiral direction. So I'm gonna add a math node, multiply this count by 2 to increase. Let's see what happens. And should comes to this part as well. Alright. Looks nice, so it's filling up the space pretty nice with all those circles. One problem here is that, as you can see, the angle of the curve seems correct, but it is overlapping to each other. You see kind of intersections all over the places. So we do need a little tweak on the rotation. I think what we could do is to add additional rotation to this align Euler to vector rotation to create an angle offset, so that we don't see much intersections to each other. So to do that, I'm going to add a vector to this rotation that I've created for either x-axis, y-axis, or z-axis on the local space. If I change x, rotates like this, maybe not what I want. For y, looks much better. if I move this to negative y axis, seems to have what I really want here. If I move this to z direction, maybe not much. So let's try to create a rotation on y axis. Okay, seems like it could create some offset without some intersections. So I'm going to create the value here, convert it into the radians so that I can input the degrees as the input, and create a vector value which only changes the y value here, and convert it here. Okay. Now controlling this scale value, negative z, and at the same time controlling the scale value, make this a little bit smaller, start to get better. I do see a small problem, still see some intersections right here, which looks a bit weird. I guess it's because we are using this auto pivot. So let's make this pivot fixed to y, maybe not x, nope, z, maybe x, y seems to work best. Okay, now we still see some intersections here. Not sure if we could fix this correctly. Okay, one additional things that I could do here, I guess, is to rotate each section curve a little bit, like for odd numbers and even numbers with specific values, so that we could have a checker pattern as a scale pattern. Right now, every scale on each column or each rows is aligned like this, but I think it's going to look a bit more better if we have more of a checker pattern type. So in order to do that, what we need to do is to go back to this section curves right here. And you can see that these points are the point position where you have the scales. So just picking up the odd numbers or even number sections and rotate by the half size of this length to either direction, I think you'll be able to create a checker pattern. So let's try to do that, and if we could fix the layout of the scales. So I'm gonna give these network a little bit go to the right side. Let's have this inside the frame. Right, and then let's see how we could do that. Now, in order to do that, we do need to rotate each of these sections somehow. Let's see how we can do that. Since these are still instance, I think what we could do is to use the one called rotate instance in order to rotate these. And in order to do that, we do need to define the pivot right now. Right now it's set to 0, 0, 0, and if we try to rotate this, okay, it doesn't really do nothing. Doesn't really do anything here right now, does it? That is because we were not showing here. Okay, so if we rotate to X direction, that's not where we want to rotate. Okay, so to the Y direction is where we want to rotate, I think. Okay, so let's control the rotations on Y direction somehow, and we only want to pick up the even number of this section's number if the index is applied by 0, starting from 0, maybe from here. Let's count from here. So 0, 1, 2, 3, 4. If that's so, then we only want to get the odd number, like, or even number, like 0, 2, 4, 6, and just rotate these curves. And for the for the odd numbers curves, we don't want to do anything. So since each instance has an ID from 0 to the total number of instances, we could use the index and use this to check whether it's on the odd number index or even number index. So we could check that by using the math node together with the modulus function by 2. So if it's 0, then that's even number. If it's equal to 1, then that's a odd number. Okay, so we only want to, let's say we want to only rotate if it's an odd number when this value is equal to 1. So if it's equal to 0, no rotation is done. So to do that, we would like to multiply this value by some angle that we want to rotate. For now, I'm gonna make this manually by converting some values to radius and multiply it. And we need to convert this into a rotation value. In this case, we only want to convert this y value for the vector. So I'm going to use the combine x, y, z to y and apply it into the rotation. Let's see if we are actually changing the rotation for a odd number. You can see that the odd number curve is only rotating like this, so that's good. Now what we need to do now is to define how much we need to rotate in order to create the checker pattern. Okay, and that's pretty easy to do because we know how many points are on each section curve or section circles, which is equal to this section resolutions. So we could use this to calculate the angle we need. So let's create a group input again. And first of all, if we have 16 points, the section resolution is equal to 16. We would like to divide 360 degrees, which creates this circle, divided by the section resolution, which gives you an angle between this point to this point. Okay, so mass node divisions the 360 degrees divided by section resolutions. And what we want to do is to rotate the half size of this angle so that we can have a checker pattern. So I'm going to multiply this by 0.5 and converting this into a radians, or we can just enter this value to here. And now it should give you a curves rotated just the half size of this angle, rotated only for a odd number curves. Okay, so let's go back and see the actual scales position on top of these curve, and now it looks much better like this. Okay, now let's try to control this angle value again and see if we could fix this intersections problem, and it seems it's much better. And maybe it is going to be better if we control this either x or z direction as well, together with this value here. or X or Z? Which one is better? Maybe not Z, maybe an X rotation seems to work better. So let's have that as a additional parameter here in order to control the Z axis. All right, seems it looks good. All right, looks good. Okay, I do see small intersections here as still. So we do need to tweak a little bit for these parameters. It's up to you. What's the best parameters? You could also change the scale, size of the scale as well, like that. Okay, but overall it looks pretty nice. Alright. Now I guess it also makes sense to be able to change the orientation of the overall spiral curve. Right now it's rotating counterclockwise, but sometimes you might want to rotate it on clockwise directions. In order to do that, I think you can just make this value negative. Nope, not really. So in that case, we actually need to make this rotation value negative for this angle right here. Which I thought by making this value negative seemed to work, but not really. Okay. Well, maybe we could use a transform node later in order to switch between a clockwise or a counterclockwise. Yeah, this doesn't really give you the result that I wanted. Okay, well, we can do that later. Now, what I want to do next is to create some animations to rotate the scales using the spiral as an axis to make it a bit more interesting for this geometry. So I want to rotate the scales like clockwise or counterclockwise using the center of the spiral curve as an axis. So to do that, we could tweak this rotation a little bit to assign some animations. So let's make this framed and create a animation based value or a frame based value to update this rotation a little bit. Okay, so to do that, we do need a parameter which gives you a time-based value from group input. Especially in 3.0, you don't have a scene time related node, so you do need to have it from the driver. So let's create the frame parameter as a float and type hash frame so that you can bring up the current frame value, which is this value here, to a geometry node through a driver. Okay. Now I want to make it as a loop animation, so in order to make it easy, I'm going to make the end frame to 360 degrees, a 360 frame, which will be useful for many usage. And now that the frame is in between 1 to 360 degrees, 1 to 360, I am going to use this frame as an angle itself to rotate the scales. So since it's from 1 to 360, you can use it as a degrees, as a rotation angle, and to do that you do need to convert it into radians. So I'm just going to directly convert this frame into radians and then just add this value to this y angle for this scale rotation and see how it's gonna work. Just add it, apply it to Y, and let's see how it goes. Now the scale already rotates pretty nicely counterclockwise. If you want to make it rotate it clockwise, you can multiply this by negative value. Like this. If you want to make it more speedy or faster, like multiply by 2 makes you really fast. Just gonna make it equal to 1 for now, because I like this animation. I think, yeah. All right. Looks nice. Looks nice already. So, in terms of the geometry, I am pretty satisfied with this. It's time to check all those parameters, and there are several parameters that I haven't created, especially these angles. So let's also make these parameterized. So let's create another group input and have these x-axis and y-axis be controllable for scales. So for this one, it is scale x scale x angle in degrees, and let's make this minus 15. This one is scale y angle. Let's make this minus 5. Right, and just delete these. And we do want to control the scale of the scale. Yeah, it's a bit confusing. Size of the scale, let's say. So connect into this here, and I'm gonna name this to scale size. And I think you can just make it as a float and convert it into vector, so that one value will be converted into XYZ. And the default value 0.2 or 0.25. Or a little bit smaller. Okay, like it. Alright, now in terms of the parameters, I think I have enough. One last parameter that I would like to set is either you want to make it clockwise or counterclockwise in terms of these turns. So to make it simple, I'm just going to use a transform node. And if you make the scales for x to -1, you can make it clockwise. So let's create some switch parameters for this scale x, either 1 or -1. So I'm gonna create a vector value, and we do have a Boolean value, which you can use, which you can have either 0 or 1. Wait a minute. I didn't want it to change this scale size to Boolean. This should be float. But instead I want to make this value, let's say clockwise to Boolean. Okay. And the Boolean is either 1 or 0, okay? And if it's equal to 1, then I want to multiply by -1. If it's 0, just want to multiply by 1. So In order to do that, I think I do need to use like something like map range. So it's in between 0 to 1. If it's equal to 1, I want to make it -1. If it's equal to 0, I want to make it 1. And like this. Okay. And I shouldn't clamp it. Okay, I actually needed to make y and z equal to 1. Alright. So if it's clockwise equal to 1, you get clockwise rotation. If it's equal to 0, you get counterclockwise rotation. Okay, it looks good. Okay, now it looks all good. It's time to test out all those parameters, if we have any glitches or not. So let's see. If I make this turn, you can control the number of turns or rotation, which is good. If we control the section, we can control the number of scales or the resolution of scales. For A, you can control the overall size. Alright. And if you control this K, you can control the exponential scaling. Okay. You do see a lot of intersections on the inward. Alright. Now let's make this small, rather small value like 1.15 so that we see something like that. And we can also control the cross-section scale. Alright, like it. Looks nice. And Z scale is how much you move on Z direction. Let's keep this 2. And the scale X angle, controls the scales on X direction or X axis. Let's make this -10. This scale Y angle controls this angle on Y axis. Let's make this 5. Oh, maybe not. Maybe it should be negative value. So -6, and for X, -15. Yeah, looks better. And we could also control the size of the scale using this value. Alright, so overall all the parameters seems to work good. We do see those intersections on inward, which we cannot really prevent because we have smaller like distance in inward. So in this kind of a setup, we should only look at the outside. If we also want to control here, we should somehow figure out how we orient this curve so that we don't see much intersections here, or maybe we could control the scale of circle itself dependent on the positions. But for this one, I'm just gonna leave it as it is. Okay, now everything is ready as a geometry. It's the last thing I would like to do is to render these inside Eevee as a real-time renderer. Now what I would like to do here is to apply some random colors to each scales, each disk, and kind of a gradient colors. And that's pretty much what I would like to do here. So what I should do in order to do that is bring up the attributes data, apply to each instances, and bring it in. So and we can use that in shader, Eevee shader. Okay, so I'm gonna change the spreadsheet to shader editor, and then I'm going to apply this material to this object, set material, and there's a default material for this geometry which is called material, so I'm just gonna use this material, go to the material view, I'm gonna rename this to spiral, and let's change this shader in order to control the color of these scales randomly. So in order to do that, we do need to create the random values inside the geometry node and apply it as an attribute to each disk. And unfortunately, we cannot apply an attribute to instances. If we look at the spreadsheet, we only have instances right now, and we cannot, seems like we cannot apply a custom attributes to these instances. So instead, we need to make this back to the original geometry, the mesh geometry. So to do that, we are going to use the realize instance. And now we have these vertices, edges, and face again. Exploded these instances. And what I could do is to apply a color value to each face, or color related, or some random values to each faces, and use it as an attribute inside the Eevee. So let's do that by creating a random color based on the number of faces. So I could use a index to first of all get the index number of the faces, and then based on this index I could create the random value. And probably I don't really need this index after all. Maybe I can just use this random value as it is, and then just connect this to the group output, one of the empty group output input. Let's change this to, first of all, a face or a scale, and change this to face so that the connected value will use the face field value. This is important here, and that's pretty much that I need to do here. Now go back to the Eevee shader editor, bring up the attribute by using attribute node for the scale, and this should give you a fractional value between 0 to 1 coming from this random values. Let's check at the spreadsheet. If we look at the face, there should be additional parameter. Okay, we're not having it yet. That is because we need to name the attribute. Right here, there's no name applied yet, so we need to name it something. I'm just gonna name it the same name as I did name here. So now you have this random values for each scales. Alright, and then go back to the Eevee shader. Now this should give you some values between 0 to 1. So based on those values, I'm gonna create some colors using the color lamp. Let's see, if it's equal to 0, I get some white values, and if it's close to 1, I'm going to get some, I don't know, pink value. So from white to pink gradation. And by connecting this float value to here, factor, you'll be able to convert the 0 to 1 value into the color values using this color ramp. And connect this into vase color, and there you go. You have now this curve faces colored with a white to pink gradation. Now instead of connecting to the base color, I'm gonna connect this to the surface color and make the surface equal to 1 so that it will penetrate the light a little bit. Okay, now I think it's also a good idea to have some shadows to make it more three-dimensional. So let's hide out the grid and set some lightings. I currently have single light value here, but this doesn't do much, so I'm going to create a directional light to control to create the hot shadows light. I'm gonna create the sun and does it create any shadows right now? Okay, it's not really doing anything. That is because I didn't click here. Okay, now it looks better. It is creating shadows, but maybe I could control the angle a little bit. Now I do see some low-res shadows here, so let's also fix that. Going into the render scene editor here, I'm going to increase the samples. Also check the bloom and check shadows. Make it really high res. Then also check high bit depths, which will create a bit more cleaner resolutions for the sun, for the shadows. Now let's change the angle to see what kind of shadows I would like to get in terms of this shape. This looks nice. This looks pretty nice. Okay, gotta define the angle, which angle we want to look at this shape. Somewhere around here. Looks pretty nice. Okay. Yeah, something like that. And as an optional light, I'm gonna use this point light to have some highlights and increase the power. And change the color a little bit. Okay, let's add some additional lightings to the bottom to have a little bit of highlight to the rear, to the edges, and also on the back side as well. So let's have another light. And change this to bluish light. Something like that. Okay. I think I like it. Alright. Now hide out the grid and go back to the shader. And maybe I could change the base color to black and raise up the substance value a little bit more to make it a bit more brighter. Maybe the backside rear color is a bit too bright. Okay, this looks nice. Yellowish. Okay, and a bit darker. Alright, so I think I like how it looks right now, and probably I could use another attribute to change the overall color gradually from frame 1 to 360 degrees, like changing the hue colors, the hue value of these colors. So to do that, I'm going to bring up the frame value to the group output as an attribute, as an additional information. So group input. So we do have this frame value as a parameter. So let's bring this as an output. Let's bring this as an attribute. And we do need to name this as well. I'm gonna name it as frame. So use this frame value, which is in between 1 to 360. We want to normalize this by divide it with 360, so that we have a value in between 0 to 1. Now we could use a node like hue saturations to change the color's hue based on this value, the time-based value. Like that. Now it gradually changes the color, I think. Does it? Not really. It's not really changing anything, is it? Okay, let's see why. So it's flowed for each point. Should be okay. And we are importing the frame value. Let me go back to the spreadsheet. See if we are having this frame for each point. Yep. Probably we do need to change this to face. No, not really. I think beam point is fine, so we do have frame value here. And we go to the shader. Okay, we do need it to make this divide. Okay, so slowly you can see that the color is changing. It's just changing the hue based value. Okay, looks good. Now I'm going to create the final frame to organize the last part, and this is it. This is it. So this is how you could create a algorithmically designed snake-like pipe shape with the scale rotating, with the loop animation looking from all those places, all those directions. It's pretty interesting, and you can control many parameters to control the shape. This also looks interesting, and so on. So I hope you find it interesting, and see if you could use it for, I don't know, more interesting project. Okay, this is it. Thank you very much, and see you next time. I am also doing a Patreon myself, so if you are interested in this kind of tutorials on like Blender or Houdini or Grasshoppers, using algorithms to design geometries, please follow, subscribe, and hope you could join the Patreon as well.